Hello, everyone. Hello, everyone. Welcome to my live. Welcome, everyone. Hi, everyone. Woo, it's been a while since I've done one of these. It's good to be back. Really good to be back. Hello, everyone. So, my name is Miss Martins. I'm going to introduce myself a few times. I'm not crazy. I'm going to introduce myself as more and more people join. Science and math students, this one is particularly for you. And in particular, I am doing a lesson for grade 11 and 12 science students. So if you have a friend that's in grade 11 or grade 12 and they need help with science and in particular electric circuits, please share this live with them. I would really appreciate that. Greetings from Colombia. Hello, welcome. Right, so my name is Miss Martins. I am a South African teacher, and today I'll be doing a science lesson. I'll be doing grade 11 and grade 12 electric circuits. So I'm going to give everyone a minute or two or three to join. But remember, if you're in grade 8, grade 9, grade 7, grade 10, whatever grade you're in, even if you don't do science, hello, South Africa Limpopo. If you don't do science, please can you share this live with your friends? It's the first live of mine for the term, and I have decided to do a topic that will help grade 11s and grade 12s, and that is electric circuits. Grade 10 maths, of course. I do grade 10 maths as well. I saw you at school today, ma'am. Hello again. Right, so please share this live with your friends. I really appreciate it. I know a lot of people are maybe still doing sport, maybe extramurals, maybe they're just arriving home. So maybe we won't have a lot of people yet today, but I am ready to help whoever I can. Comment your grade, please, below. I like meeting new students, so let me know if this is your first time on one of my lessons. And also let me know what grade you're in and what topic you would like help with. So I do maths and I do physical sciences. So let me know what grade you're in and what topic you would like help with, or what topic you're currently doing in class. These comments are very important to me because I take note of what topics you're currently doing, what topics you're struggling with, and then I obviously do my lives according to what the majority of the people want to do. Hello, Zozo, in grade 10, not the first time. Well, welcome back. Okay, so remember your name, and then how are you not exhausted after work? I am exhausted. Can you see my face? It's all red because I'm tired, but I know everyone's tired, and I just want to help you guys. Okay, so I see someone's asking me about private tutoring. I just want to get it out the way at the beginning now to start off with. If you go to the link in my bio, so you do need to follow me, and then go to the link in my bio. If you click on the link and you scroll down through everything that I've got there in my link tree, you will see that I say online workshops for maths and online workshops for science. If you are interested in potentially taking part in online private tutoring, it is small group tutoring, so it's not one-on-one, but I do small group tutoring where you can actually speak to me and interact. You can go on that link, you can fill out under sign up for my workshops, and then I will contact you via email. Okay, so where can I find this live after you are done? If TikTok lets me save it, I will upload it to my YouTube channel. So my YouTube channel is also linked in my bio. Okay, so lastly, I'm going to get going because I see that we're already 3 minutes in. My name is Miss Martins. I do maths. I do physical sciences. Please share this video with your grade 11 and 12 science friends. I'll be doing electricity today. As the live goes on, I would really appreciate it if new people join or just share it or whatever. Grade 12 electricity. Okay, that's what we're doing today. Yay. Okay, awesome. Let's get going. So I will be flipping the camera. Hopefully, you see, this is the problem with this. I don't know, TikTok has done this thing where I used to be able to flip the camera, and now it doesn't let me flip the camera. Okay, let me just double check to see if I can do this. Oh, there we go, I can flip the camera. Yay. Okay, I'm going to flip the camera and we're going to get started. I can still see the comments, so please carry on commenting. Let me know what you want to see. I'll probably do physics for grade 10 next. I'll probably be focusing on things like balancing and a little bit of stoichiometry. All right, let's get started. Remember to share the video with your friends. Okie dokes. So flipping the camera. Now, please comment down below if you are in grade 11, you take science. And if you're in grade 12 and you take science, please let me know. Do I have any grade 11 and grade 12 physical sciences learners in the live at the moment? Please let me know. I see someone says, when am I doing physics? What time will I be doing physics for grade 10? I do my lives all at the same time, so I do it at 4 o'clock. It's not on a set date. However, I don't know. I will let you guys know in advance. So you just need to keep a lookout on my TikTok accounts. Please let me know if there are any grade 11 and 12 science learners. Okay, I see some matrics. Hello, matrics. I see some grade 11s. Fantastic. Okay, let's get going. What I have in front of me, or what you can see on your screen, and I hope it's not too blurry, please let me know as I carry on going if you're in grade 11 or grade 12, just so I can see how many of you I have in here. Okay, so as you see in front of me, hi Claire, I have the examination guidelines. This is for grade 12. Now, some of the grade 11s that are in this lesson might think, okay, but why is ma'am showing us the exam guidelines for grade 12 if we're in grade 11? I do lessons for grade 9s, yes. And the reason why is even though you are in grade 11, you need to access these things. These are called exam guidelines. And I'm sure you've heard about them. You can find them, just Google exam guidelines, grade 12, physical sciences, and they will pop up. Right, now why they are important is because when they set your exams at the end of the year, they use these exam guidelines and they basically, everything that they say here, this is what you need to be able to do for your exams. Everything listed here. All the definitions listed here. So defined power is the rate at which work is done. All of this stuff is stuff that they can ask in your final exam paper in grade 12. But your grade 11 teachers, those of you that are in grade 11, they also use this and this helps them set the exam papers. Okay, so if I look at the exam guidelines for grade 12, remember this applies to grade 11s as well. You can see that you need to know Ohm's law. You need to be able to work with series and parallel circuits. You need to be working with all these different things. You need to be working with internal resistance. Now, the grade 11s that are in the chat or in this lesson, please comment if you have learnt about internal resistance. At the school where I work, we teach grade 11 science. They do internal resistance. But I know at other schools, they only do internal resistance in grade 12. So let me know if you have done it as grade 11s and grade 12s, or if you've not done it yet. Then you need to know about power and energy. And you need to know how to calculate the cost of electricity. Okay. Right. So I'm going to start off with Ohm's law. Then I'm going to go on to power. Then we're going to first look at circuits without internal resistance. And then to end off, I'm going to look at circuits with internal resistance. And the reason I'm doing it like that is so that the grade 11s in the chat, they can still take part in most of the lesson. And if they want to stick around for internal resistance, it's only something that some schools test and teach in grade 12, but you are welcome to stay around for it. I'll go through it briefly at the end. So these are the definitions that I've extracted from the exam guidelines that you need to know. The first one being Ohm's law, the second one being EMF, and the third one being power. I will come back to these definitions as I go through the topic. These are my formulae, and I made the summary for grade 11 and 12 students. If you have not done internal resistance, you will not know what this formula is over here. But everything else you should be familiar with. So this is a formula I use to calculate potential difference across 2 points in a circuit. It's the work done per Coulomb charge. So work in joules, charge in coulombs. Then I've got the formula to calculate current, which is the amount of charge that passes a certain point per unit time. We can't see it all. Must I zoom out a bit? Okay, there we go. Is that a bit better? Okay, there we go. So Current is the amount of charge that passes a point per unit time. That's why I use charge and time to give me current. Then we've got Ohm's law. Now this is what I'm going to start going over. Ohm's law is essentially the relationship, or it helps explain the relationship between voltage, current, and resistance. And I'm going to show you this triangle. We're going to go over that. Then you need to know how to calculate resistance in series versus parallel. And then we are finally going to look at power and energy. And we're going to use these formulae to help us calculate the cost of electricity, which you should be doing in grade 11, but grade 12s, it's something that you generally learn in grade 11, but it is tested in matric. So look at the exam guidelines. There we go. You need to be able to calculate the cost of electricity. This is from the grade 12 exam guidelines. So we're going to go over that. Now, these are the formulae that I showed you on my summary. I'm not going to spend too much time going through this because this is something that you should have done in grade 10. If you don't know what's going on here, I can upload a sheet for you. Let me know what your thoughts are on that. I've got a sheet called Electric Circuits where I summarize each formula. I give the formula, I tell you the units, I tell you how the formula works, and I give you some definitions. Would you like me to upload this sheet to the link in my bio, the Google Drive in my bio? If you would like it, please comment, let me know. I'm more than happy to do that for you. I've got some stuff on internal resistance over here. I've got some stuff on Ohm's law, so I can upload that for you guys. But you need to know how to use this formula and when to use what formula. Let's go on to the units. Now, grade 11s and 12s, this is important. And the reason why I say that this is so important, okay, I see a lot of you want the notes. I will upload for you. Okay. The reason why I am taking time out of this lesson to tell you about units, which is something that you think, oh, that's easy, I just learn it. People don't put their units in their science papers and you lose marks. I don't know if you're aware, but every answer that does not have a unit, you lose a mark. And if you put the incorrect unit, it doesn't matter if you did the calculations correct and you got the correct number. If you, for example, said that charge was not in coulombs, let's say you said A or J or whatever, you get it wrong. You need to know the quantities and the units associated. And you always need to quote your units. So from this table, I just want you to also note that work and energy, we use it interchangeably, and the unit is joule. Power, the unit is watts. Those are new. You learned it in grade 11. Charge, resistance, current, potential difference. You should have learned that in grade 10 already. Okay, so it's the small things that people don't know how to do. Now, Ohm's law is something that, again, the grade 11s are currently learning that. So if you're in grade 11 and you know what Ohm's law is or you've learned it, please let me know in the comments. I like to know what other schools are doing because obviously I always go according to my school, but my school might not do what your school does. So it'll help me to know what your school does so I know how long to focus on certain things. So, Ohm's law. If we think about the definition of Ohm's law, and I do have a definition for you. Here it is. Ohm's law, okay, the potential difference. We should know what potential difference is. It's another word for voltage. The potential difference across a conductor is directly proportional to the current, so current is I, in the conductor at a constant temperature. Now, something that I always emphasize to my students, my grade 11s and my grade 12s, is that when you're mentioning a relationship, so here I'm mentioning the relationship between potential difference and current, you need to tell me what type of relationship it is. So it's directly proportional, which means if the one goes up, the other one goes up. Okay? So if current increases, potential difference increases. That's what directly proportional means. Also, when you are mentioning a relationship, you need to tell me which variable is constant. So here I'm saying that it's at a constant temperature. Another way to state Ohm's law, and grade 12s, you need to know this for your exam, is by this relationship over here. I don't know if your teachers have shown you this symbol, but that symbol is another way of writing directly proportional. So that symbol is another way for writing directly proportional. So what this says is voltage is directly proportional to current at a constant temperature. And the formula that can help illustrate this is Ohm's law. And we know, or you should know, that you can rewrite this formula in a variety of ways. So for those of you that have seen my TikTok videos, you would have seen that I put up one where I show this triangle, VIR. This triangle helps me get the formula. It's V is equal to I times R. So voltage, if I'm looking for voltage, it equals to current times resistance. If I'm looking for resistance, cover resistance, it's equal to voltage divided by current, like that. And if I'm looking for current, cover current, it's equal to voltage divided by resistance. It's the same formula, just rearranged basically. But what I want you to understand is Ohm's law says that current, which is this value, is directly proportional to voltage. So if this goes up, this goes up. But the temperature must be constant. Now, if I plot that on a graph, it should look like this. Voltage, current. So if voltage is on your y-axis and current is on your x-axis, you get a graph that looks like this. And we all do maths. All science students should do maths. If you do maths, you'll be able to tell me how to calculate the gradient of that graph. So if we look at it, I'm going to do it from scratch. If I have this, how do we calculate gradient, everyone? So this is voltage. It's on my y-axis, voltage. This is current, measured in amperes. Amperes. It's on my x-axis. How do I calculate gradient? So this is a straight line graph. If I have a straight line graph, I can calculate the gradient. The gradient is equal to, for those of you that do maths, hopefully your maths teacher taught you, it's change in y over change in x. That is how you should have learned gradient in maths and in science. Change in y over change in x. Now, if you look at this graph, what is on your y-axis? Change in y is voltage, so change in voltage. And on your x-axis, I've got current. Now, what do we know about voltage divided by current? Voltage divided by current, what does that give me? Voltage divided by current gives me resistance. There we go. Voltage divided by current gives me resistance. Someone asked, is this supposed to be grade 12? This is grade 11, but it is taught again in grade 12. In grade 12, it gets more complicated, but for now, we're going to focus on the more basics. We're going to build up to more difficult. Okay, so the gradient will give you resistance. Now, just take note that if I swap the axes, so here it was voltage on the y and current on the x. If I swap them and put current on the y and voltage on the x, then this is going to swap. Then my gradient will be change in current over change in voltage, and that no longer gives me resistance. What does that give me? What does that give me? Change in current over change in voltage. That gives me 1 over resistance. So, Tamsin, are you going to go over internal resistance in this lesson? I definitely will if I have time. The idea was to help the grade 12s that have problems or struggle with the basics. So the basics from grade 11. So my main goal for this lesson is to do grade 11 work, which is also tested in grade 12. And at the beginning of the lesson, I showed you the exam guidelines. All of the grade 11 stuff is tested. There's Ohm's law. All of this stuff that I'm doing now, you learned in grade 11, but it's tested in grade 12. So I wanted to do the foundations and then build up towards internal resistance if I have time. Okay. I do chemistry. Yes, I do. Donkey. Okay. Right. So if voltage divided by current is equal to resistance, voltage over current is resistance, then current over voltage is 1 over R. So we can actually ask that in a variety of ways. Let me show you. Here's a graph illustrating Ohm's law. You can see it's a line of best fit. If we get a line of best fit through the origin, it means that my conductor is ohmic. Ohmic conductor. If it does not obey Ohm's law, you see straight line, ohmic. This is not a straight line through the origin. Then we've got non-ohmic. You need to know that for your matric exams and grade 11 exams. Right. If we look at this grade 12 exam question, for example, what we can see here, and I'm going to have to zoom in a little bit, so I'm going to cut off some of the notes. That's fine. I just need to zoom in. This graph looks quite bad, but it's just the printing. They want to know the independent variable. Now, I don't know if you guys can see, but this is how I remember dependent versus independent. Dependent is the one that we measure, and it's generally the one we plot on the y-axis. Dependent, and then the independent is the one that I change, and I plot it on the x-axis. So the dependent, D for dependent, is the one that we measure, and the independent is the one that we change. Okay, so the independent variable would be potential difference in volts, and the dependent variable would be current. Okay, now the variable that must be controlled would be the temperature. Okay, temperature. Remember, Ohm's law basically says that the temperature must be constant. The potential difference across the conductor is directly proportional to the current in the conductor at a constant temperature. We can see that this graph obeys Ohm's law. It's a straight line going through the origin. We can conclude this from the graph. So that's what I did there. Current is directly proportional to voltage if temperature is constant. Then they want you to use the gradient of the graph to calculate resistance. Now what I did is I first calculated the gradient. And when you calculate gradient, you need to use 2 points. When you calculate gradient, you need to use 2 points or 2 coordinates. I listed the coordinates that I chose from the graph over there. The one being the origin, 0, 0, that coordinate. And the other one being this coordinate over here, which is very difficult to read, obviously, from where you guys are sitting and from what you can see on the phone. But I promise you that it's that. Okay? Then you work out gradient. Gradient is change in y over change in x. My y is my current, my x is my potential difference, and I get that value. But now remember, the gradient in this case is not equal to resistance. The gradient in this case is not equal to resistance. And that's because the gradient is change in y over change in x. In this case, my y is current. Okay, my x is voltage. I divided by V, that is not equal to R, it's equal to 1 over R. So when I get my gradient, which is 0.36, I make that equal to 1 over R, and then I solve for R, which is resistance. So basically the reciprocal. Now this is grade 11 work, but once again, it can be tested in matric. Does everybody understand? And I know that there are some people in the lesson that feel like this is easy. And I say this in every single one of my lives. If you find what I'm doing boring because it's too easy, I'm actually so happy for you and I genuinely mean it. The reason I go slowly and the reason why I do maybe more of the foundation things is because there are some people that don't understand. There's no way you're going to be able to do the difficult stuff if you can't do the foundation things. Okay. Right? Understand? So I need you to please let me know if you understand this concept. I see someone is saying, listen kids, this teacher's good at pointing out mistakes. I hope that's not sarcasm. I do mark matric papers, so I know where learners go wrong. I know where you go wrong because I have experience marking. So I see like silly mistakes. You know what I mean? Okay, moving on. Now, this is going to seem extremely easy for the people in the lesson, but I need you guys to answer this. Okay, I need you to answer this. Someone said I'm in grade 9. Why is this on my For You page? I teach grade 9 as well. Okay, that's why it's on your For You page. And I don't only do maths and science. I do study tips and stuff as well. Okay, so this is going to be super easy. So for the people that know this, I'm sorry that I'm being boring. Let's go over this. In series, something splits and something stays the same. This is how we go over it. In series, what can I say about the current? What can I say about the current? In series, the current stays the same. I do grade 10 as well, yes. Current stays the same. This is very important. And some people are going to laugh at why this is so easy. If you don't know this, you can say goodbye to electricity and you can skip the question. And I don't want you to do that. So what that means is in series, the total current flows through this branch over here. That means that the reading on A1 is equal to that reading on A2, which is the same as the reading on A3, which is the same as the reading on A4, which is the same as the reading on A5. The current is the same everywhere. Everywhere. Okay? The voltage. What about the voltage in series? It splits. So what that means is the voltage across the battery, V1. How do I get V1, the voltage across the battery? I take this voltage, and that voltage, and I add those together to give me the voltage across the battery. So V2 plus V3 plus V4, those three added together gives me the voltage across V1. Exactly, add all voltages. 1000%. Let's go into parallel. By the way, for the people that are currently in the lesson, I just want to say it again in case you didn't hear it in the beginning. If you are interested in smaller group, private tutoring that I do not on TikTok, I do on Google Meet, please go to the link in my bio and find the link where I say workshops. You can sign up and I'll send you an email about it. Okay, I do maths and science. And the grades that I do, that I'm currently doing, they're listed in my, they are listed in my bio. Poor math teaching. No wonder few are interested. Okay, well, if you're not interested, you can leave, because I don't know why you would take time out of your day when I'm actually helping people. Okay, moving on. Parallel. So what can I say about the current in parallel? The current in parallel splits. So that means A1 measures the total current, and that current will split between A2, A3, and A4. Okay? So A1, the total current, is equal to the current in this branch plus the current in this branch plus the current in this branch. The total current is equal to the current in all three branches add together. And you need to understand that when the total current, so the total current will flow through here. When it gets to this point over here, there's a split. Okay? It can go either through R2 or through R3 or through R4. Okay. I see some people are telling me, okay, to upload the notes. I can do that. Moving on. The voltage. What about the voltage in parallel? The voltage is the same. However, be careful. There's another resistor over here. So here's the voltage across the battery. Let's pretend that it reads 10 volts, the voltage across the battery. There's a resistor over here connected in series. Let's pretend the voltage across that resistor, let's call it V2. Let's say that reads let's choose another number. Let's say 6 volts. So across the battery is 10 volts. That over here, this resistor, let's pretend the voltage across that resistor in series reads 6 volts. What would the voltage across the parallel combination read? 10 minus 6 is 4 volts. What that means, now this is very important, is that the voltage for resistor 2 is 4 volts. For resistor 3 is 4 volts. For resistor 4 is 4 volts. Because resistor 2, 3, and 4 are connected in parallel, the resistance across those resistors are 4 volts. Okay. Thank you so much for the encouragement. Some of you, very, very sweet. I appreciate it so much. So resistor 2, 3, and 4, because those three are connected in parallel, the voltage across those is the same. But because this one is in series, this one, resistor, this component in the circuit is 6 volts plus these 4 volts gives me the 10 volts. Right, let's move on to an easy example. When I say easy, I mean that the there's no internal resistance. No internal resistance. So the battery's resistance is negligible. Right. It's a pleasure, guys. I really love helping you guys, and I really hope I am helping, not wasting my time or whatever. Okay. Calculate the effective resistance of the circuit. So how we do that is we always look to see, yes, I am left-handed. Always look to see if I have a parallel combination first. And yes, I do. There is a parallel combination. Then what I'm going to do is I'm first going to work out the effective resistance for the parallel combination. Once I have that, whatever that value is for resistance, I'm going to add it to the 2.6. Okay, so let's go. 1 over RP is equal to 1 over R1 plus 1 over R2. This, if you are not aware, that is the formula. This is for grade 11 and grade 12. That is the formula used to calculate the overall or the effective resistance of resistors in parallel. So these two. So we're going to go 1 over 4 plus 1 over 6. And now remember, this is 1 over RP. So 1 over 4 plus 1 over 6 is 5 over 12. But that is for 1 over RP. I don't want 1 over RP. I want to know what resistance in parallel is, RP. So I need to take the reciprocal. So what I do is I flip that fraction around. Then I flip that fraction around. Yes, this is grade 10 stuff actually. And I get 12 over 5. 12 over 5, which is 2.4 ohms. Then what I need to do is to get the total effective resistance of the circuit, R total. I'm going to take what I got for the parallel, so 2.4, and I'm going to add 2.6. Okay, 2.4 add 2.6, and I get 5 ohms. That's the effective resistance of the circuit. Why do you add the series resistance? Okay, good. Good question. So the question asked me to calculate the effective. Another word for effective is total or overall resistance of the circuit. So because I want of the entire circuit, I calculate the resistance for the parallel piece, which is 2.4, and then I add the resistance series. Okay, you have to. Where did the 5 come from? So what I did is, you can do this without a calculator, but I just used my calculator. 1 over 4 plus 1 over 6, 5 over 12. Okay, 5 over 12, but that's 1 over RP. So because I flip this to get RP, I must flip this. Okay, next question. Calculate the total current in the circuit. Now we just calculated that R total was 5 ohms. And what is the total voltage? It is 20 volts. Someone asked, so this circuit is both series and parallel. Yes, 100%. This circuit contains a parallel combination or parallel part and a series part. Well done. Okay, so my total resistance was 5 ohms, which I got from the previous question. And my voltage is 20 volts. So V equals 20 volts. They want me to calculate the total current in the circuit. Now, my question to you guys is, which of these ammeters measure current, which of these ammeters will measure the total current? That should be relatively straightforward. It should be this ammeter because it's connected in series over here. It's not in a branch is what I mean. Okay, A1 measures the total current. So we've got I is equal to V over R, 20 over 5. So the total current is 4 amperes. 4 amperes. Now, calculate the reading on A2. A2. Now, let's look at where A2 is. Why does A1 calculate total? Okay, so A1 calculates the total current because it's connected in series like this. The only time it doesn't calculate the total current is if it is in a branch. So you see it splits off here, and A2 is in the top branch. That means that this calculates the split current. This one, A1, is in series, so it calculates the total current. Okay, So calculate the reading on A2. Now, I don't know how you guys do it. There's lots of different ways to do it, but the one way that we can calculate the current in A2 is to use ratios to split the current. So let's call this resistor 1 and resistor 2. Okay, resistor 1, so R1 to R2. What is the ratio of resistance over there? It's 4 to 6. 4 to 6. And if I simplify 4 to 6, what am I going to get? I'm going to get 2 to 3. Okay? That's the ratio of the resistance. That I'm going to put an R there. Now, if you look at these two resistors, 4 ohms and 6 ohms, which resistor would get more current? So if you look at these two resistors, which one, the 4 ohm or the 6 ohm, which one will get more current? The 4 ohm or the 6 ohm? So the rule is, the smaller the resistor, the bigger the current. Okay? So the smaller resistor gets the bigger current. And that is why this is the ratio of resistance. The ratio of current is the opposite. Okay, this is how we do it. So the smaller resistor, which is the 4 ohm, gets the bigger current. You see, it's got a smaller resistance. The 2 to 3, 2 is smaller, so it must get the bigger current. So it must be 3 to 2. Now, to work out what current goes through the 4 ohms, what I do is I use ratios. So the 4 ohms is this side of my ratio, so the 3. How do I split using ratios? So my total current is 4 amperes. So to split using ratios, I add the parts of the ratio. So 3 plus 2 is 5. So you can either go like this. You can either go, while I'm looking for the current through the resistor 1, which is the 4 ohms. So I go 3 over 5 times 4. That's one way to do it. 3 over 5 times 4. So the top resistor will get 2.4 amperes of current. Another way to do it is to take the total current, 4, divided by the part of your ratio. So there's my part of my ratio, 3 and 2. So 5 is my total part. So 4 divided by 5, and I'm looking for the current in R1. So I need to times it by 3. You get the same answer. Yes, you can use the current divider formula. Yes, there are other ways to do this. Okay. If you want more examples like this, I can upload a video on my YouTube channel, but this is something that you should have done in grade 10 actually. Okay, let's move on. Now, I want to vote in the comments, and I'll go with the most voted option. Would you guys like me to do power and calculating the cost of electricity? So power and electricity, or internal resistance. So I'm going to give you guys like 30 seconds to vote because I have notes for both, but I want to know which one to start with because, yeah, they can take long. So power and cost of electricity or internal resistance. Now remember grade 12's internal resistance. Okay, woo, I'm getting a lot of comments. Okay, I'm going to have to scroll up to read this. Remember grade 12's, you will be tested on both. You will be tested on power and cost of electricity and internal resistance. Grade 11s will not be tested on internal resistance. Okay, I'm not sure which one's winning here. I'm seeing quite a lot of both of them. Okay, I'm going to start off with power because I think I see more power. But I'm going to quickly move on to internal resistance. Okay, power, please. Internal resistance, power. Okay, let's start off with power. Let's not waste time. So these are the formulae used to calculate power. So power is, I will get to internal resistance, I promise. Power is the rate at which work is done. And when I say rate, so rate at which work is done. Every time you see the word rate, you know I'm going to be dividing by time. Another symbol for energy is work. So if I take work divided by time or energy divided by time, I'm going to get power. Oh, remember to share this live with your friends, please, your science friends, so maybe they can catch the last bit of the live to help them with power and internal resistance. Okay. So It's the rate at which work is done. These are the other formulae used to calculate power. Power is the voltage associated with the component or whatever multiplied by the current flowing through it. And from these two formulae, we can get these other formulae. Now, here's another summary that I can upload for you guys, but essentially it goes through what power is, it goes through how to measure power, and it goes through the equations. So I will put that up. The thing that I want to show you is power is energy divided by time. So energy would be equal to power multiplied by time. Thank you so much to everyone who's sharing the live. I appreciate it. The goal is to help as many people as we can. Okay, so power is energy divided by time. So energy, if I want to isolate energy, you say power times time. Now, when it comes to calculating the cost of electricity, which is what we care about mostly, which is what we're working towards, we're going to calculate the amount of energy transferred to a device in kilowatt hours. Now, why people get thrown off with this is because kilowatt hours, people think that is, well, actually, let's see what you guys say. Kilowatt hours, what is that a unit for? What is that a unit for? It's a unit for, tell me, is it a unit for, what is it a unit for? Okay. Tell me what you think. Kilowatt hour, is it a unit for energy? Is it a unit for time? Is it a unit for power? Ooh, okay, I'm seeing lots of different answers. So most of you are saying it's a unit for power. And you see, I completely understand why you would think kilowatt hours is a unit for power, because it's got watts in it. And watts is power. But look at this. Power, we generally measure in watts. Correct. Time, we generally measure in seconds. But what if I tell you that I want you to measure power in kilowatts? Kilowatts. And I want you, so I'm going to put kilowatts in brackets, that's my power. And I want you to measure time in hours. If I take my power, which is my kilowatts, and I multiply it by time, which is my hours, I get kilowatt hours. And power multiplied by time is energy. So kilowatt hours is actually a unit for energy, not for power. Okay, so when we calculate the amount of the cost of electricity, you should stop jumping from topic to topic. Last time I checked, I was doing energy equals power times time, and I've been doing that for a few minutes. So energy is power multiplied by time, as I was saying. Now, when we calculate the cost of electricity, so let's say the cost that a geyser uses, the cost that a kettle uses, the cost that a microwave uses, we quote that in terms of kilowatt hours. So that's how electricity is sold. Let's do an example, and this should make sense. But basically, my steps for this, what I want you to do is when we calculate costs, I want you to calculate the amount of energy. Energy is power times time. Power must be in the units kilowatts. Time must be in the units hours. Now, just quickly, how do I go from watts to kilowatts? How do I go from watts to kilowatts? Watts to kilowatts, I divide by 1,000. Watts to kilowatts, I divide by 1,000. Okay, that's very important. So I convert my power to kilowatts, I convert my time to hours, I get kilowatt hours, I take whatever that is and I multiply it by the cost. An example, calculate the cost of electricity to use a geyser, you know what a geyser is, it heats water, for 12 hours. Note, the power of the geyser is 2,500 watts. Now, step number 1, I need to calculate the energy, and I need my units to be kilowatt hours. Okay, so energy is power multiplied by time. Now, my power, I said 2,500 watts. I need my power to be in kilowatts. So how do I convert that watts to kilowatts? It will be divided by 1,000, so 2.5. This is easy. I gave you time and hours already. So 2.5 times 12. 2.5 times 12 is 30 kilowatt hours. Okay, now look what I said at the top. Electricity is sold in kilowatt hours, and this was the price, I don't know, like a year or whatever ago. It differs. So it's 2 rand per kilowatt hour. Therefore, that means that 1 kilowatt hour is 2 rand. Therefore, to get the total cost, I take the number of kilowatt hours, so kilowatt hours multiplied by the cost. What I say by cost is tariff. It's this number over here, per kilowatt hour. So it's 30 times 2, which is 60 rand. So to run the geyser for 12 hours, it costs 60 rand. Well done, guys. Should we try one more quickly? 60 rand, yeah. So it's 2 rand per kilowatt hour, but I've got 30 kilowatt hours. So kilowatt hours is basically the unit of energy. It's the amount of kilowatts used per hour. Right. Let's do one more example. Calculate the cost of using a kettle if you take 5 minutes to boil a 2000 watt kettle. The cost of electricity is 2 rand per kilowatt hour. Hello, from South Korea. That's awesome. So remember, this cost can change. They can give it to you. It differs. So what do I need to do first? I need to work out power. So power is equal to energy times time. And remember, because my tariff or my cost is kilowatt hour, I need my power to be in kilowatt hours. So I'm doing this wrong. Not wrong, I just messed up my formula. Energy is power times time. So I need my power to be in kilowatts, and I need my time to be in hours. Okay, so my power element is, I did make a mistake. Sorry, I swapped my formula around. My power is 2000 watts, so it's going to be 2. Okay, kilowatts. Okay, someone said I must include the units. That can be helpful. And my time must be in hours. Now, 5 minutes. How do I convert minutes to hours? How do I convert minutes to hours? Oh, I see someone's from Greece. Hello. So to convert minutes to hours, I need to divide by 60. So to convert 5 minutes to hours, you divide by 60. So 5 over 60 is 1 over 12 hours. Okay? 1 over 12. So you times 2 kilowatts by your hours, which is 5 over 60, or 1 over 12 hours. Then 2 times 1 over 12 is 1 over 6 kilowatt hours. See, kilowatts times hours gives you kilowatt hours. You can write this in decimals as well, but don't round off because we're not at the end of the question. So the total cost is the kilowatt hours multiplied by your tariff. We call it a tariff. It's basically how much money you pay per kilowatt hour. So if my kilowatt hours is 1 over 6 and my tariff is 2 rand, what is 1 over 6 times 2? 2 rand. I'm going to get 0.33 rand. And obviously, if you want to, you can convert that to cents. So it's 33 cents. There's 100 cents in a rand. Okay, I hope that makes sense. So just to recap, what you do is you get energy. Energy is power times time. Your power has to be in kilowatts. Your time must be in hours. That gives me energy in the unit of kilowatt hours. The reason I want the unit in kilowatt hours is because that's what my cost or my tariff is quoted in. You take your kilowatt hours that you calculated, you times it by the price per kilowatt hour, and you get your total cost. Okay. Right. Now, to end off, I'm going to go over, see guys, I have a whole lot of questions that I want to do. So if you would like to be part of lessons where I go over this, not on TikTok, but other lessons where you guys can unmute your mic, ask me questions, whatever, go to the link in my bio and sign up. But I'm going to do a quick introduction into internal resistance. Okay, internal resistance. Now, what I need you guys to understand is that if I connect a voltmeter across the battery and the switch is open, that voltmeter reads the EMF. So I'm going to write it in over there. So grade 11s, you don't have to stay for this, but I mean, you're going to be doing it next year if you haven't done it already. That reads the EMF. When the switch is open, current is 0, so I is equal to 0. And the voltmeter connected across the battery reads the EMF. Right. Then, if I close the switch, that voltmeter no longer reads the EMF. So the EMF is the maximum energy provided by the battery per unit charge. See, there's my definition for EMF. The maximum energy provided by the battery per unit charge. So when the switch is open, it measures EMF. When a switch is closed, it reads what we call V external. Other words for V external is V load or V terminal, whatever you want to call it. Now, I'm going to use actual examples to illustrate this. If my EMF, let's pretend that the EMF was 12 volts. This is when the switch is open. Then the switch is closed and V external is 10 volts. So this is when the switch is closed. So switch is open, no current. The voltmeter across the battery reads 12 volts. Switch is closed. V external is 10 volts. What happened to the 2 volts? What happened to the 2 volts? What do I call that? Does anyone know in the chat? What do I call those 2 volts over there? So EMF is 12, V external is 10. Obviously what happened is there were some volts that were lost. And we call this, the official name for it is V internal. But a lot of schools refer to it as V lost or lost volts. And the reason why we call it lost volts is because the battery has an internal resistance called baby R. This is called internal resistance. And because of the internal resistance, some of the energy is used inside the battery. Okay. Because of the internal resistance, some of the energy is used inside the battery to get the charges to move through the battery. So the battery heats up and that energy is lost or dissipated due to heat inside the battery. Okay. Now, one way that we can represent this is we can say, okay, cool. So what happened was I had 12 and that was made up of the 10 and the 2. So I hope you were following. The 12 was the EMF. The 10 was V external. The 2 was V internal. Okay. The 12 was the EMF. The 10 was V external. The 2 was V internal. So in other words, V external and V internal together give me the EMF. This is one of the basic formulae I can use to calculate EMF. However, I know from Ohm's law that V is equal to I times R. So instead of V external, I can write I, which is current, times R external. So that's the external resistance of the circuit. Then, instead of V internal, remember V is equal to I times R. So what do you think V internal is equal to? V is equal to I times R. So for V external, it was I times big R. Grade 11s, you are more than welcome to leave. This will be in your exam. Thank you, Josh, for the finger heart. This will be in your exam next year. So, I mean, you can learn it with me now if you want. V internal is equal to I times little r. Now, R, yes, I do say it like that. Now, what is the common factor in this expression over here. This is total current, that is total current. The total current flows through the circuit, the total current flows through the battery. So I can take out I as a common factor, and I'm left with R plus baby R. That's equal to EMF. Okay, and that is the formula that we now know for EMF. Okay, I, R plus little r. Now, when you do calculations, your calculations, so there I did it again. I hope that helped some people. There is another explanation. That's when the switch is open, that's when the switch is closed. EMF minus V external gets you V internal, all of that stuff. Then I broke up each one. I took I out as a common factor, all of that stuff. And then we can answer questions. Now, this is a very basic circuit that we can do. Very basic. What it says is I have a battery with an EMF of 20 and an internal resistance of 1 ohm. And it's connected to 3 other resistors. There, 5, 10. Those are in parallel. I hope you can see that. And then the 8 ohm. Now they want to know the current in the 8 ohm resistor. There. How I would approach this question is if you see a circuit and you have EMF and you have internal resistance, by the way, this is how we draw a battery, more or less, most of the time, if we have internal resistance. So we draw the cells and we draw a little baby resistor to represent baby R, internal resistance, and we draw a dotted line around it. So this entire thing is basically the battery. Now, how I would do this is if you see EMF and internal resistance, I would write out my EMF formula. So EMF is equal to I, open bracket, big R, plus baby R. Now, what I always do is I look at what I have, look at what I'm looking for. I have EMF, it's given to me, it's 20. I have baby R, it's given to me, it's 1 ohm. I'm looking for current. Now, note what they say. They want the current in the 8 ohm resistor. In other words, the total current. How do I know that? Because the total current will flow through the 8 ohm resistor. So they want total current, so this is what they're looking for. In order to use this formula, I first need to calculate big R. Now, how I would calculate big R is like we did in the previous example that I did this lesson. So what you would do is you would go, okay, cool. I need to calculate big R, which is R external. In other words, this part plus this part. So we start with the parallel combination. 1 over Rp is equal to 1 over R1 plus 1 over R2. Now, grade 12s, you should know that you need to put your formula first in order to get the marks. No formula, no mark. 1 over 5. 1 over 5 is my 1 resistor. 1 over 10. I get 3 over 10. So 1 over Rp is 3 over 10. But remember, I don't want 1 over Rp. I want Rp. So I flipped that over to get Rp. I need to flip this over. So it's 10 over 3 ohms. And just if you prefer decimals, which is fine, it's 3,3333 ... ohms. Remember, don't round off yet. That is the resistance over there. Then I need to add this resistor over here. So therefore, the total R, external, big R, is 10 over 3 plus 8. So that's going to be 11.333 ... ohms. Another way to write that could be 34 over 3. Now, the reason why I'm leaving it as a fraction now is because I'm not done with the question. What I did in blue over here is I worked out big R, R external. So just remember, big R is the external resistance of the circuit. So the parallel plus that. Now I still need to find my current. So I go and I substitute into my EMF formula. So one more time, EMF is equal to I, big R plus little r. Big I is what I'm looking for. EMF is 20. big R is 34 over 3. Yes, you can substitute 11,33333 in it, but I just left it as, the fraction. And little r is 1. Okay, can everyone still hear me? Then what I do is I say 20 divided by that term. Okay, so 20 divided by that term, and I get my current to be 1,62 amperes. Okay, did everyone follow that example? I know that was sort of quick, and I know that it was also a sort of easy example, but remember what I said at the beginning of the lesson? I really wanted to do the lesson for grade 11s and grade 12s. I really wanted to go over majority of what was in the exam guidelines. And a lot of it was stuff that you learned in grade 11. So Ohm's law, we did power, energy, calculating the cost of electricity. And then we started introducing EMF, the EMF formula, and I did a basic calculation. I do want to do more with you guys, but unfortunately, let me just I just want to talk to you guys for a second. Unfortunately, my time has run out, and TikTok does this thing that, like, if I go over the hour for my live, it just stops the live, which sucks. But anyway, basically what I wanted to know is if you enjoyed this live and you are keen to maybe join lessons of mine, do you work at Kids Beach? No, I work at a high school. If you want to join lessons that are similar to this, but not on TikTok, they will be on Google Meet, and it'll be smaller groups. So you can unmute your mic, you can talk to me, you can say when you don't understand, like it's more, one-on-one-ish, sort of. Not one-on-one, but you know what I mean. Then go to the link in my bio and go to the little tab where I say workshops. You can sign up on there. Do you even post on YouTube? So I do, but I don't. I post my lives on YouTube, and every now and then I do want to try and upload a video. It is very difficult because I do work as a full-time teacher, and the lessons that I record for my students in class, we're not actually supposed to upload those onto YouTube. It's actually not legal because I'm recording it for the students in my class. They pay me as a teacher for that school. So if I upload it to YouTube, then I could make money off of that of YouTube. It gets complicated. Guys, don't stress about it. But basically, I don't really want to upload videos of stuff that I recorded with my students in class onto YouTube. Also because those videos aren't very good quality anyway. So I do these TikTok lives, they go on my YouTube channel, and I am trying to find more time to do YouTube. But yeah, there's only so many hours in a day. I'm still trying to figure out my time management and stuff. Do you have a patron? No, I don't. Yeah, that's it. This is just me here. So please keep an eye out on my TikTok page. If you follow me, you should see when I do lives. I do other grades, and I'll probably do grade 10 science next, maybe some maths, not sure. But anyway, thank you so much. When are you doing organic chemistry? That's a good question. I don't know if I'll do a live on that on TikTok, but I might do one on my Google Meets thing. Such a pleasure, everyone. Hi, my mom emailed you about my brother's mouse. Okay, I will go check my inbox. Some of my emails have been going to junk for some reason. Okay. I wanted to be one of your students, but your English is too much and you're fast. Oh, I'm so sorry. Okay, awesome. Oh, thank you guys. You all mean so much to me. Keep watching my TikTok videos. I will try my best to post study tips and stuff. You teach me more physics than my own teacher. Oh, I really love that I can be a teacher for you guys on this platform. So remember, although you're not sitting in my physical classroom, you are in my classroom. You're always welcome to ask me questions. Okay, when you're doing physics for grade 10, I'll probably do it next week. Okay, guys. Goodbye. Thank you for joining me. Remember to follow me and comment on my TikToks what you want to see next. If you comment, I might make a video answering you. So Victoria, what grade is your brother in? Just let me know. Yeah, if you comment on my TikToks, tell me what you're struggling with, tell me what you want to see notes for, what you want to see lessons for, or just ask a question in general. I might just answer you. Okay, awesome. Goodbye, everyone. Okay, grade 8. Okay, cool. Bye, guys. Love you all. Oh my goodness. My thing is going weird. Okay, are you going live tomorrow again? No, I'm not going live. Next week. Next week. I'll see you guys next week. Bye, guys.